So we begin today's video discussing DNA repair and mutations. So we start by discussing a healthy dividing cell. During the course of a healthy dividing cell, you may have some DNA damage. Now, during this division or prior to the division, you may detect some damage to that DNA, a missing base pair, or a replaced base pair, or a mismatched base pair, or a damaged chemicals, or incorrect backbones to the DNA. At that time, what's going to happen is there are going to be DNA repair enzymes that go to work here, and they're going to stop cell division. The cell cycle is going to halt. We'll have cell cycle arrest, as it were. We're going to assess the damage, and we're going to try and repair that damage. Now, there will be three outcomes in varying orders of severity. The repair can be successful, in which case the damage is repaired, and the cell returns to the cell cycle, and healthy cells are divided once again. And then we have the damage being too extensive to repair. If the damage is too extensive to repair, then the cell basically holds up its hands and says, well, we gave it a good run, time to pack up and go, and begins the process of programmed cell death, apoptosis. And through that process, it just degrades all of its internal organelles, separates itself into apoptotic bodies, and is cleaned up by macrophages. So programmed cell death is the result of too much DNA damage to repair. If the repair fails, but the damage is not sufficient to cause the death of the cell or to activate the cell's apoptosis sequence, then we will have damage accumulating over time. Now, when that damage accumulates, we will have effectively a new gene mutation. So we'll have a normal cell dividing into normal happy daughter cells that are perfectly happy and perfectly high fidelity, and no mistakes were made. Then we have mutations. A mutation doesn't necessarily mean anything happened at first. At first, nothing may go wrong. At first, things may be okay. And that cell line will continue. But as that cell line continues, we may get another mutation. And then that might change the appearance of the cell. It might change the way that cell looks, or the way that cell behaves, or an enzyme that cell produces may no longer function, or the enzyme that cell produces may take on a different function, or it may start overproducing or underproducing an enzyme. And then that cell line continues. Now, at that point, once again, we return. If the damage is not repaired, if the repair is successful, we go on and we're fine. If the damage is unsuccessful or too extensive, we destroy the cell. Or the repair fails and the damage accumulates. So if the damage keeps accumulating over time, we will have more and more different shapes, colors, and behaviors of cells. These traits will be different over time. And this may cause nothing, or it may cause a cancerous mutation. And those cancerous mutations could be the loss of the DNA's repair mechanisms. It could be the loss of control of the cell cycle. It could be a change to the way that the cell receives and sends signaling for its growth factors. Any number of those things. The more those traits accumulate, the more mutations that stack up, the more that cell is going to change from its original structure. And the more chances you have of it becoming a problematic mutation, a cancerous cell line. So let's talk about the stages of cancer. We have our initial tumor cell. We have one cell that acquires mutations and causes loss of control of cellular division. So this will lead us to a cell that divides more frequently than its surrounding neighbor cells. And it will start to take up more space than its neighbors. All right? That will lead us to a carcinoma in situ, an on-site carcinoma, a carcinoma that is still confined to the region where it originated. A carcinoma in situ stays where it was born, and it does not cross this basal lamina right here. The problem begins, the problem can begin when this cell starts secreting hormones and cytokines and other stuff that can cause downstream effects in the entire body, or when the cell becomes malignant. Now, cells of a malignant tumor, we have an invasive carcinoma, where the cell has invaded past the basement membrane and has invaded neighboring tissues. That is a locally invasive carcinoma. And what happens worse is when the cells can break apart and travel by blood or lymph to distant organ sites and set up shop in that new location and start growing a new tumor in that location. Common tumor locations for metastases include the liver, the lungs, the back, the spinal, the base of the spine, and the brain. So those are some pretty common metastatic sites. Depends on the tumor, of course. So this is the spread to distant sites. That's metastasis. That is the hallmark that defines a metastatic malignant tumor. Now, let's talk for a moment about the difference between benign and malignant tumors for a moment. This is a visual overview of the difference between them. In a benign growth, benign does not mean not dangerous. Benign just means it's not actively trying to invade. In a benign growth, the abnormal cells will typically be walled off in a connective tissue capsule. They will look a lot like each other, and they may even be somewhat similar to their surrounding normal cells. In a malignant tumor, the cells of the tumor may not even look like cells of the tumor. They may look completely different from one another, and they will look totally, radically different from normal cells in the surrounding tissue. These will typically not be walled off in some kind of connective tissue capsule. Now, that's what we call well and poorly differentiated. Well differentiated are cells that are as well differentiated or similarly well differentiated as the cell of origin, as the cell type of origin. The well differentiated benign tumors will, the individual cells will appear similar to their fellow cancer cells, but they can appear different from their surrounding normal tissue under a microscope or visibly if the tumor is quite large. Whereas in a malignant tumor, they're often poorly differentiated, where the individual cells will appear very different even from their fellow cancer cells. You can easily distinguish a malignant tumor from its surrounding cancer cells under a microscope, and if the tumor is large, you can definitely tell the difference between the cancer tumor and the malignant tumor and the surrounding healthy cells. The problem is that you can't always remove all of the malignant tumor from the surrounding healthy tissues because of how it grows. It grows without boundaries in a number of different directions and branching everywhere. And even one cell of a malignant tumor in a location can start an entirely new tumor, again, if you leave any one behind. So with benign tumors, typically their rate of growth will be different from malignant tumors. They'll divide and grow and displace surrounding tissues rather slowly versus malignant tumors, which will do that quickly. And benign tumors, like I said before, will be contained within a fibrous capsule, and there will be no such capsule in a malignant tumor. They'll be fully capable of invading neighboring tissues. And benign tumors tend to remain at their location of origin, whereas malignant tumors, they are going to spread. That is what defines them. Spread is what defines malignancy. Now, the way that a benign tumor can cause damage to the unfortunate person who has these tumors is through mass effect, and that's not the video game. That is a effect caused by the mass that is the tumor. So if you were to put a tennis ball under your arm and actually carry that tennis ball and compress it under your arm for a good period of time, you would actually start to feel the cutting off of blood flow to your fingers and hands, and you would start to feel numbness and tingling. That is a mass effect. So that is an effect caused by compression of something, that is caused by compression of the tissues, specifically the brachial artery in your arm. So mass effect is compression or displacement of local tissues. You can also have a benign tumor cause a problem through paraneoplastic effects. Paraneoplastic. A neoplasm is also a way of saying cancer. Changes to the humoral factors is a paraneoplastic effect, like the balance of hormones and cytokines, or immune responses to the tumor. And yes, your immune system can respond to tumors. They are technically self, but sometimes they can be so radically different that your immune system will even respond to tumors. And that is actually one of the control mechanisms against cancer. Your immune system can fight cancer for you and prevent cancer, but you are handicapped in that the tumor went undetected before it had built up enough of these mutations to become non-self. So that's part of the problem. Now, a malignant tumor can do everything the benign tumor can do. It's one of those Annie get your gun situations. Anything you can do, I can do better. No, you can't. Yes, I can. All right. So most of the malignant tumors will cause death by invasion of local and distant tissues. That's where most malignant tumors will cause their greatest death. However, they can do everything benign tumors can do. They are capable of causing just as much mass effect and paraneoplastic effect damage as benign tumors, depending on what that malignant tumor is, its identity, its location of origin, what kinds of mutations it has. So that's where we are. But before you get too confident that now you know everything there is to know about benign and malignancy, understand that benign and malignant exist on this spectrum. There is no one thing that you say, well, that's benign and that's malignant. There is definitely a gray area where you have locally aggressive benign tumors or low-grade malignant or borderline tumors, and you've got variable growth rates, local infiltrations, intermediate patient survival rates, and the like. And for there are 0 to 50 different kinds of cancer for each letter of the alphabet. And each of those cancers can come in a variety of different flavors and stages and what have you. So the saying goes, there are as many kinds of cancer as there are people with cancer. So this is complicated. It is difficult. And that brings us to basically what you can do, my little public service announcement stage. Effectively, the single most effective controllable risk factor that you have control over is not smoking cigarettes. If you have started smoking cigarettes, stop. Quit now. If you have not started smoking cigarettes, keep that up. Do not start smoking cigarettes. If someone in your life smokes cigarettes, convince them to stop, because secondhand smoke is not just as dangerous, it is very dangerous as well. So, other things that you can do in order of how it can help you. Don't drink alcohol. Alcohol is effectively an environmental insult. So alcohol can lead to an increased risk of various different kinds of cancer, especially of the liver, of the stomach, of the esophagus, of the throat, of the gastrointestinal system, of the colon, especially those organs. So that is a big no-no. Like, drinking alcohol is a big risk factor for cancer of a lot of different organs. It is an overall increased risk as well. Smoking increased risk of almost every kind of cancer. If it doesn't increase the risk, then it only doesn't do anything. There is nothing there is no cancer that cigarettes will prevent. They will only either not have any correlation with, or they will make it worse, or they will give you an increased risk. So there is no benefit. Now, wearing sunscreen, and I can pretty much guarantee you that you're probably putting sunscreen on wrong. Read the instructions on the bottle of sunscreen for how to apply, and you may be surprised. I'm just gonna you can go ahead and pause the video and I'll wait for you to do that. Just gonna look at my non-watch right here. Okay, we're 2 hairs past the freckle. Let's move on. All right, another thing you can do. Considering my audience's age range, I'm assuming my audience's age range, of course, who knows? At this point, this is the internet after all. Getting vaccinated against HPV. The recommended vaccination time is 11 years old for HPV vaccination, but you can get vaccinated past that age, should you so choose. Some pediatricians will choose not to, especially if you've already had sexual intercourse. But effectively, HPV is human papillomavirus. It is a sexually transmitted cousin of the herpes virus. There are 4 strains that are of consequence, that are HPV 8, 11, 16, and 18, if I'm remembering correctly, and it has been a while, so once again, the comment section will explode if I am wrong. There are 2 that cause, these are all 2 that cause warts and 2 that cause cancer. So the cancer-causing HPV strains are capable of causing cancer of the genitals, throat, anus, pretty much any mucosa that you transmit the HPV virus to. And you can prevent contracting HPV with the vaccine. If you have already contracted it, then, well, it's basically putting on a raincoat when you're already wet. But effectively, if you want to prevent being infected with HPV, you should definitely get the HPV vaccine. I believe there are 7 strains or 40 strains of HPV overall, but I think there's 7 to 13 strains that the HPV vaccination actually prevents nowadays. Once again, I could be wrong, and everybody's wrong on the internet. All right, so healthy diet. A healthy diet increases your protection against cancer in the same way that a healthy diet increases your protection against any kind of disease. It improves your immune system response, and your immune system is designed to assess and remove threats before they become a problem. So a healthier immune system will actually take down cancer cells before they become an issue as well. Healthy diet and healthy exercise routine are both in the same vein. Exercise and healthy diet have both been shown to decrease relative risk of cancer overall, and decrease overall mortality, decrease the overall risk of mortality by age group. And the data has been remarkably consistent on this factor. Now, in terms of what you can do to detect cancer early, now we've talked about basic prevention. Let's talk about detection. You need to have a regular checkup with a primary care provider, a PCP. You need to have a trust relationship built with this primary care provider, because no one else will have the expertise and know you like a primary care provider will. They'll be able to say, well, last time you came in with these complaints, how is that going now? An ER physician will not be able to do that for you. They are either overworked or they are simply not designed around that model. And a walk-in clinic of that in the same vein is also not designed around that model, as well as